Hey everyone. So we left off talking about 11.1 and using law of sines to find missing angles or sides of an oblique triangle. And so in 11.1, law of sines required us to have a ratio of the side length and the angle. And so we looked at case one, which was on SAA, which is side angle or angle side angle. We use law of sines first. Or I'm sorry, because you were given two angles, we use sum of angles to find the third angle, and then we use law of sines to create our ratios and solve using our proportions cross multiply. And then the second case that we looked at in 11.1 was side angle, where we started off by having a ratio, but we ended up looking at the fact that this particular case gave us three types of solutions. So you could either have no triangle possible, one triangle possible, or two triangle possibles. Excuse me. And then we talked about where we need to stop to see how many triangles we're actually going to end up with. And so in 11.2, we are dealing with case 3 and case 4. Case 3 is side angle side, and case 4 is side, where you don't actually have any of the ratios. So we can't actually use law of sine. And then you're also introduced to this idea, which we didn't talk about in class, of side length restrictions, because you are actually giving two sides and you're trying to find the third side. You need to make sure that you check the restrictions on the side length. It turns out that two sides, the sum of the length of any two sides must be greater than the length of the remaining side. So they give us this example where one side is 3 and the other side is 4. 3 plus 4 gives me 7. And that's not a possibility because 7 is less than 10. So the two sides, or any two sides of a triangle, must be greater than the third side. So that's just also to just kind of check your calculations when you end up getting the three sides. You want to check that all of that is good. So again, we're looking at case 3 and case 4, which is going to require us to look at the law of cosines instead of the law of sines. However, you will need to go back and do the law of sines anyways. So here's the law of cosines. It is a little bit more difficult to remember, which again, you're not required to put this in your math toolbox. You're not required to memorize these, but you definitely want to have these on your cheat sheet so you can use it on the day of the test. It's a little bit more complicated than law of sines, but it's still very nice and doable. And I also gave you sort of a summary of how to look at each case. So if you're looking at case 3, which is side angle side, and how does this differ from case 1? Because you still end up, or case 2 where you end up with two sides and an angle, is that this angle that you're going to be given is in between the two sides, which will lead to not having an actual ratio, right? So you're going to not end up with side A, angle A, or side B, angle B, side C, or angle C. You end up with the side in between two different angles, so I can't actually jump into putting this as a ratio. So in order to solve for an SAS triangle, we're going to use a law of cosine to find the third side. And then now that I have that, I can go ahead and apply the law of sines because I end up with the ratio. What is important here is that you want to use the law of sines to find the smaller of the two angles. And then you're going to go ahead and use the sum formula to find the remaining angle. Okay, so this is really important. Find the smaller of the two remaining angles first after you do law of cosines. For a side, same again, you're going to use the law of cosines, but in this case, you're going to find the largest angle first. Remember that the largest angle goes with the largest side. And then it really doesn't matter which one you find afterwards, just as long as the first one was the largest angle. Okay? So please make sure that you are following that. So here it says find the unknown side A and in the triangle shown. So we're looking for side A. We are given that this is an side angle side triangle. Side B, angle A, and side C. Notice that A happens to be in between B and C. Okay, so that's that. So how do we go about looking at side angle side? The first thing that we want to do is find one of the sides. We want to find the side that is corresponding to angle A. So I'm going to use our law of cosine, where we have A squared is equal to B squared plus C squared minus 2BC cosine of A. Depending on how you like to do your calculations, I'm going to go ahead and take the square root already, just because it's sort of much easier. So we're looking at the square root of B squared. So little b is 5.0 squared plus little c, which is 11 squared minus 2 times little b times little c times cosine of 52 degrees. And you can input all of this into your calculator, or you can go ahead and simplify this a little bit and then use your calculators to get this. You should end up with 8.8. Remember that you were given two significant figures. 52 is two significant figures. 11 is two significant figures. 5.0 is two significant figures. So we're going to leave our answer as 8.8. So side A is equal to 8.8. Here's example 2. It says the surveyor wishes to find the distance between 2 points A and B. So we're looking to find this distance on opposite sides of a lake while standing at point C. She finds the measure of AC, which is 259 meters, and the measure of BC happens to be 423 meters. Angle ACB. So remember that the angle would be the one in the middle. So it's angle C is 132 degrees and 40 minutes. And we want to find the distance to the nearest meter. What we can do is just kind of call this little c. And we can use our c squared formula to get us there. Don't forget, it is a good idea to just kind of write out the triangle. And you're not asked to find all the missing values, so we're kind of not following through that step by step. We are just looking for side C, so we're just going to go ahead and use our C squared formula, which is equal to A squared, which we do have, plus B squared minus 2AB cosine of C. And again, I'm going to go ahead and just take the square root of that so that now I can calculate this much easier. So A squared, A happens to be 423 meters. B happens to be 259 meters. So it's squared minus 2 times 423 times 259 all times cosine of that, which is 132 degrees and 40 minutes. And again, using your fancy calculators, fancy phones, we should end up with a side length of 628 meters. And that's again rounding to 3 significant figures. That's example 2. In example 3, you'll see that we actually do have to solve for the triangle. So let's go ahead and see how that works out. So we're going to solve for triangle ABC. First thing we want to do is try to draw a triangle. Here is A, B, and C. Angle A happens to be 42.3 degrees. Can't get the point where I want it to be. My stylus. Let me try this one more time. 42.3 degrees. Little b, which is across from angle B, happens to be 12.9. And little c happens to be 15.4. So remember that to solve the triangle means that I'm looking for all of the missing pieces, which in this case would be angle C, angle B, and side A. Again, if we scroll back up, well, first thing we want to do is this is going to be a side angle side. And if we go back to our little cheat explanation, it says use the law of cosines to find the third side, and then use the law of sines to find the smaller of the two remaining. Okay, so again, we can find side A by using our nice law of cosines. So we'll start there. So use law of cosines. And then it is A, so we're going to look at A squared, which is equal to B squared plus C squared minus 2BC cosine of A. And so I'm going to go ahead and take the square root of that so that I can easily put it in my calculator. And we end up with 12.9 squared plus 15.4 0.4 squared minus 2 times B times C times the cosine of angle A, which was 42.3 degrees. Don't forget that your calculator must be in degree form. So once I do my calculation here, I end up with a side length of 10.5. And remember that this is 10.5 meters. So now step 2 is to use law of sines. So we go back to law of sines. But remember that we want to use law of sines to find the smaller of the two angles. So if we take a look at our triangle here, right? We know that A is 10.5. We know that little b is 12.9 and little c happens to be 15.4, which means that C is going to be the larger and B is going to be the smaller. So we're going to go with B. So we're going to use law of cosines to find the smaller angle, which now we can use A to find angle B. So little a happened to be 10.5. Angle A was 42.3. B is 12.9. And we're looking for sine of B. So we're going to cross multiply here. 10.5 times sine of B is equal to 12.9 times sine of 42.3. And to get sine of B by itself, we take all that and divide by 10.5. And again, the more times you do this, the more steps that you may want to skip. You should end up getting that B is equal to 55.8. So now that we have the two angles, angle A that was given to us and angle B that's 55.8, we can finish the triangle by now using the sum of angles formula. Which I'm going to sort of skip through the entire step. But basically, you guys know that you take 180 minus both of the angles that you have to find that third angle, and that should give you 81.9. So angle C is 81.9. And again, right, how do we know our calculations were right? Well, angle C happens to be the bigger angle, so we know that it's going to correspond with the biggest side, which is 15.4. Angle A was the smallest angle. Little a was 10.5, which is the smallest side. Another thing that you can look at is the angle sum. So 12.9 plus 15.4 must be bigger than 10.5, which it is. 15.4 plus 12.5 is much bigger than 12.9. And then 15.4 plus 10.5 is definitely bigger than 12.9. So we are good. So we have all of the angles that we are missing, and then the one side that we were missing as well. So let's go ahead and do it again. We'll do a couple more of these and then jump onto area. How we can find the area of oblique triangles. Because again, prior to today, we were able to find the area of a right triangle because we need the height of a right triangle, right? Base times height, or 1/2 times base times height divided by 2 is the formula for to find the area of a triangle. What if you don't have a height because your triangle is sort of oblique? You only have the sides. So that's another question that gets answered in this section. So let's do another one of these, and then we'll do a side triangle. Or actually, this is a side triangle. So here is my not so great triangle, A, B, and C. And we're told that little a happens to be 5, little b happens to be 6, and little c happens to be 9. Again, we are at a side triangle. And if we go back to our cheat sheet, it says I'm going to use the law of cosines to find the largest angle. And again, the largest angle is going to correspond to the largest side. So in our case, C is the largest angle. Okay. So we'll start there. So again, we are only given sides. We're only given sides, so we need to go ahead and find the angle C. Notice that if we go to our law of cosine, in order to find angle C, I'm going to need to solve for cosine C, and do it that way. So one thing I can do is I can plug everything in and then solve for cosine C, or I can solve for cosine C right away. It is up to you. Whatever your heart desires. I'm going to go ahead and plug everything in first and then do that. But let's start up by figuring out what we're missing. So we're missing angle A, angle B, and angle C. And so based on the cheat sheet, it said that we need to look at the largest side first. So I'm going to use law of cosines. To find angle C, which means that I'm going to use C squared is equal to A squared plus B squared minus 2AB cosine of C. And again, you are welcome to start by getting cosine C first and then plugging in. That's sort of the way that I would do this. But I think it could be easier if we put in the numbers. Sorry, my children are going crazy. So we have 9 squared is equal to, 5 squared plus 6 squared minus 2 times 5 times 6 cosine of C. So we know that this is 81. 25 plus 36 minus 2 times 5 times 6. So 2 times 10 times 6 is 60. Cosine of C. And again, we're trying to solve for cosine of C, so we want everything else to the other side. But again, we can still simplify this a little bit more because 25 and 36 can be added together. We have 81 is equal to 25 plus 36, which is 61, minus 10 cosine C, which means I want to move the 61 over to the left, leaving me with negative 10, negative 60. Oh my gosh. Negative 60 is what I should have written down because 2 times 5 is 10. And then times 6, sorry. So we should end up with negative 60 cosine of C. 81 minus 61 gives me a nice 20. And all that's left to get cosine of C by itself is divided by negative 60. And cosine of C would equal to negative 1/3. I'm just simplifying 2 over negative 6. And then don't forget that to find C, this is just a cosine inverse of that. So C is about 109.5. So we have angle C. And then we want to now use that to find the next angle. And in this case, it really doesn't matter which one you find next. You're just going to use the ratio for C. So law of sines now, because you actually have a ratio. Let's go ahead and find angle A. So we know that little a over sine A is equal to C, little c, over sine C. So little a happened to be 5. We want to find sine A. C is equal to 9. And sine of 109.5. We do the math here. We end up with 9. Sine of A is equal to 5 sine of 109.5. Divide everything by 9. And sine A ends up being 5 sine of 109.5 all over 9. So A ends up being 31.6. Now that we have angle C and angle A, we can use the sum of angles formula to find the last angle. I'm going to try to squeeze it in here. So we can have it. So turns out that B is going to be 180. And I'll just do it this way. 31.6 minus 109.5. So angle B is going to be 38.9. All right, so again, for side, you want to find the largest angle, which corresponds to the largest side, using law of cosines. Then you want to use that ratio to find the additional angle. It really doesn't matter which one you choose. We chose A here. And then you want to finish this off by using sum of angles to find your last, angle. I don't want to make this video too long, so I'm going to skip these two really quick. But I am going to give you guys the solutions so you guys can check yourselves at home. Here's triangle ABC. You're given little a to be 9.47. You're given little b to be 15.9 and little c to be 21.1. And again, you're looking for A, B, and C. This is a side. So angle A, angle B, angle C. This particular case, C is still the largest, so this is where you want to start. Use law of cosines. Then law of sine. And then you're going to use your sum of angles. And again, I'm going to give you the solution here so that you can check yourselves. Angle C is 109.9. A was 25. And B was 45.1. So go ahead and do this one and see if you come up with those results. Oh my gosh. All right, and then I'll give you this one as well. This one is find angle B. So you're looking for this angle. Notice that this triangle is a side triangle. Notice that angle A here is the largest. So again, you're going to go through the same thing, and it actually turns out that angle B is going to give you 33 degrees. So go ahead, go through the process, and then make sure you're getting 33. So again, the second part of this section is dealing with the idea of areas. So in order to find the area of a triangle, we need to find the height. However, some oblique triangles don't have the height, and so we have these two different formulas that sort of help us find the area of a oblique triangle. In order to find the area of an oblique triangle, okay, if we have a side triangle, so the triangles are only or the information about the triangle is only its sides, then I have to use this formula where the semi-perimeter needs to be found first by using the semi-perimeter formula, and then I can use the area formula by putting in that semi-perimeter. Oh my gosh, my highlighting is just all over the place. I promise y'all I'm not doing that on purpose. So we find the semi-perimeter, which is the sides added up and then divided by 2. And then we find the area by plugging it into the formula. So let's go ahead and start on one of those. And then the second area formula is one where you are given 2 sides and the angle in between the 2 sides, okay? So you can only find the area of these 2 types of triangles if you're giving all the sides or if you're giving the side angle side. So let's take a look at the first example here. It says the distance as the crow flies from LA to New York is 2,451 miles. From New York to Montreal is 331 miles, and from Montreal to LA is 2,427 miles. What is the area of the rectangular region having these 3 cities as vertices? And we're going to ignore the fact that the Earth is curved. I mean, it is curved, but we're just using this example to help us use the area formula. All right, so first, this is an SSS triangle, which means that in order to find... Okay, so basically I just lost everything that I just did. So I'm going to have to do this again and write all this all again. However, since the video is still good, we can just start here. Okay, so this again, Jesus. This is an SSS triangle. And since this is an SSS triangle, we need to first find our semi-perimeter. So the semi-perimeter, which is S, is 1/2 the sum of all 3 sides. So our S here is going to be 1/2 times 2451 plus 331 plus 2427, which again, using our fancy calculators or our fancy phone, we should get a semi-perimeter of 2,604.5. So now we can use our area formula. So our area formula is equal to the square root of S times S minus the length of A times S minus the length of B times, S minus the length of C. So we can plug our values in now. So S happens to be 2,604.5, and then we're going to times that 2,604.5 minus A. This is going to take up the whole space here. Excuse me. Minus A, which is 2,451 or 2,451. Times S again, which is 2604.5, minus B, which is 331, and then the last one, which again we have 2604.5 minus 2,427. Using our fancy phones or our fancy calculators, we get an area of a big number, 401,664.11 miles. And that's how we find the area of a triangle with all of its sides given. Now let's go ahead and do the next one. So here is our triangle ABC. Notice that this is a triangle that has the angle in between two sides. So this is a side angle side. So we're not going to use Heron's formula. We're going to use the area of a triangle formula, which is the second one. And so notice that we were given angle B. So we're going to use the third one, which is the area is equal to 1/2 AC sine of B. So here we go. Area is equal to 1/2. A happened to be 34 feet. C happened to be 42 feet. And big B happened to be 55 degrees. Fancy phones, fancy calculators, we should end up with an area equal to 584.9. Questions? Well, can't ask me questions right now, but yeah, that's pretty much on the area. Let's take a look at one last example, and then the video will be done, and you guys can get started on your assignments. So let's find the area of the triangle ABC. A happened to be 24 degrees and 40 minutes. Little b happens to be 27.3. And big C happened to be 52 degrees and 40 minutes. Notice that this is a angle side angle triangle right now, and we don't technically have a formula for an angle side angle, so we either have to have all of the sides to use Heron's formula, or we need to have the side of one of the missing angles. So one way to do this as well, we can find the missing side of one of these angles by using law of sines first. Notice that we do have two angles, so we can use our sum of angle formula first. To find angle B. And that's going to give us the ratio for little b over sine b, so that we can find any of the other ones. So we'll do that. So angle B is going to equal to 180 minus 24 degrees and 40 minutes minus 52 degrees and 40 minutes. So angle B is going to be 102. And I didn't put this back into minutes or seconds, into degree minutes and seconds, just for purposes of time, so we know what angle B is. So now we can go ahead and use law of sines. And we don't have to find all of these sides, we just need to find one additional side so that we can use Heron's formula, the second formula. If you wanted to find all the sides, then you can use Heron's formula. But using that's a little bit too much because you have to find the semi-perimeter first. So it's annoying. All right, law of sines, we have little b, sine of b, and we'll just find a. So little b happened to be 27.3. Sine of b happened to be 102.6. Little a is what we're looking for. Sine of a is sine of 24 degrees and 40 minutes. So we end up with a times sine of 102.6 is equal to 27.3 times sine of 24 degrees and 40 minutes. And we want to divide all of that by sine of 102.6. So A is going to end up being about 11.7. So we have little a, which is 11.7. And now we can use our area formula. Since we have a, little b, and sine c, we can use our area formula that states that the area is equal to 1/2 a b sine of c. So the area is equal to 1/2 a, which happened to be 11.7, b, which happened to be 27.3, and c, which happened to be 52 degrees and 40 minutes. So the area, using our fancy phones and fancy calculators, should give us 127 centimeters. Don't forget that. And a centimeter squared. I'm sorry that the end was a little bit choppy. It's just I was really upset that all of the notes for prior to this have been deleted. So now I have to go back and do this all over again. Thankfully, not the video, but at least a writing piece. Y'all have a wonderful rest of your weekend. I will see you guys on Monday.